Welcome to qnawire.
Given the sample, you would first want to calculate the sample mean. You can do it by hand by adding the 11 elements together and dividing by 11, or using a statistical calculator. But that mean is about 20.09. And the standard deviation is about 4.89. And then we want to calculate the standard error of the mean as the sample standard deviation over the square root of the sample size. So it would be 4.89 over the square root of 11. And 4.89 over the square root of 11 is about 1.4744. I'll do that to 4 places. And so for a 99% confidence interval, the z-score, the critical z is 2.576. And the confidence interval is going to be the sample mean plus or minus the critical z times the standard error. And so our sample mean was 20.09 plus or minus 2.576 times 1.4744. And our lower boundary, we're going 2 places for the sample mean. I'll go to 2 places in the confidence interval. So 20.09 minus 2.576 times 1.4744 is 16.29. And the upper boundary from adding is 23.89. All right, and then for part B, for the hypothesis test, our sample size is 36, our sample mean is 19.02, our sample standard deviation is 5.73, and our significance level is 0.1. And so the null hypothesis would be that the true average amount of time taken to assemble chair models is 20 minutes. And the alternative hypothesis is that it is different. And so since the sample size is large and we do know the population standard deviation, no, we don't actually. We should use a t-score. Again, I'm going to go with the t-score because we do not know the population standard deviation. And so that's going to be x bar minus mu over s over the square root of n. And so that's going to be 19.02 minus 20 over 5.73 over the square root of 36. And that is negative 1.026. And I'm going to compare it to the critical t. So the critical t with 35 degrees of freedom, that's 1 less, at the significance of 0.01. The critical t values are positive and negative 2.724, and our test statistic is not as extreme, so we would fail to reject the null hypothesis. There's not enough evidence.